Hello students, in this video we will be seeing IPV4, a type of classful addressing. This topic is the continuation with the previous topic. There are two types of IP addresses, static and dynamic. Static IP addresses are given as a manual input by the network administrator for a small networks. It requires a careful checks to avoid duplication, because if there is any duplication occurred, the system will trigger a IP conflict message so that you cannot able to access internet at all. Second one is dynamic address. The dynamic addresses, for example, BootP, that is Bootstrap protocol, is a client server protocol designed to obtain the above given information like IP addresses, subnet mask, router address, IP address of the name server from the disk computer or a computer booted for the first time. The DHCP, Dynamic Host Configuration Protocol, which we will be seeing later in this video, will be discussed later. And these dynamic IP addresses are assigned by the server when the host boots, that is, when you switch on your system, the system itself will be allocated with the new IP addresses by this help of protocols. And they are derived automatically from a range of addresses. When the duration is completed, when the duration of this particular IP address is completed, then the IP address is released back to the server. Classful addressing. IP addresses, when started a few decades ago, used the concept of classes. In the mid of 1990s, a new architecture called classless addressing was introduced and will eventually supersede the original architecture. However, part of internet is still using this classful addressing, but the migration is very fast. The architecture, which is shown below, describes the classful addressing. The table which is shown here describes the addresses per classes. So there are totally 5 classes allocated in classful addressing, namely class A, B, C, D and E. Based on the number of addresses, the usage, that is the allocation percentage, is given here. As we have seen that 2 power 32 is the representation to represent IP version 4. For class A alone, it is 2 power 31. So class A alone comprises 50% of IP addresses across the globe. Class B is 2 power 30, which accommodates 25%. Class C is 2 power 29, which accommodates 12.5%. Class D is, as you can see, it is 6.25%, and Class E is also 6.25% of the total IP addresses used across the globe. There are two notations, namely binary and decimal notations, available to represent classful addressings. Among these bytes, the first byte represents which type of class does it belongs to. For example, in this binary notation we can see that class A, in the first byte it is represented as 0, and class B, always the first byte should be having the number of 10, class C with the 110, class D with the 110, and class E is always represented with the 4 ones. The first byte, which is having 8 binary digits, determines which class it belongs to. Similar to binary notations, an equivalent decimal notation is given here, where the class A will have the first byte of 0 to 127, class B will have the range between 128 to 191, class C in the range between 192 to 223, class D 224 to 239, class E, the last class of classful addressing, ranges between 240 and 255. By seeing the IP address itself, we have to find out which class does it belongs to. For example, 3 different IP addresses given here. The first one starts with 127.0.0.1. So by seeing the first 3 bits 127, we have to fix up that this particular IP address belongs to class A. And second IP address 172.16.0.9, this particular IP address belongs to class B. And the third IP address starts from 192, belongs to class C. Next important parameter we are going to see here net ID and host ID. The net ID determines the network address while the host ID determines the host connected to that network. In Classfull addressing, the network address, that is the first address in the first block, is the one that is assigned to the organization. The range of addresses are automatically be inferred from the network addresses. From the figure we can see that in Class A address, especially the net ID is assigned for the first byte. Similarly, for Class B addressing, the first 2 bytes are allocated for net ID. Similarly, for Class C addressing, the byte 1, 2 and 3 are allocated for network ID. Whereas this Class D and Class E are allocated for multicast addresses and for Class E is reserved for future use. Next, we see here about the mask. A subnet mask is a number that defines a range of IP addresses available within a network. A single subnet mask limits the number of valid IPs for a specific network. Multiple subnet masks can organize a single network into small networks, which is called as a subnetwork. For example, an entire institution may be given with a single IP address, where each and every systems present in particular college can be allocated with the mask, that is subnet mask. The network address is the beginning address of each block. It can be found by applying the default mask to any of the addresses in the blocks, which includes itself. It retains the net ID of the block and sets the host ID to the 0. Fine, we have come to the end of this topic. We will see the next topic in the next video. Thank you.